These remote audio recorders are great for monitoring really hard to get to areas where it's difficult to collect data in person. The audio recorders can be left out for months at a time.
The challenge with these audio recorders is that you can end up with hundreds of hours of audio recordings. So the question is, how do you get relevant information about the birds out of those recordings? One possibility is using machine learning algorithms to identify bird sounds, and that's definitely the way of the future. But currently, those methods only work for some species in some situations, and they can often fail pretty badly. And they require a lot of special expertise in machine learning and computing. So at this point, those methods are still out of reach for a lot of bird researchers. So we were thinking about a normal wildlife biologist, say at a government wildlife agency, who wants to use remote audio recording to monitor birds, but doesn't have expertise in machine learning. Could we find a method using humans to listen to the recordings that would give us good estimates of the relative abundance of these birds?
And the answer was yes. We found that if we listened to 10 randomly selected 1-minute chunks of the recording, we got pretty good estimates of relative abundance for most species. The key finding is that the method worked better when we listened to 10 random minutes from each day rather than 10 consecutive minutes.
So if you do a survey in person, you often count birds for 10 minutes in a row. You walk or drive to a site and then you count birds for a while, and then you leave and go to the next site. But with a microphone strapped to a tree, there's no need to be constrained to sampling for 10 minutes in a row. You can listen for the same amount of time, 10 minutes, but you sprinkle those minutes randomly throughout the day, and that makes each minute give you more new information about the birds.
So really the key takeaway from our work is that anyone who knows how to identify bird songs in person can now use this method to monitor birds using remote audio recorders. You don't need expertise in machine learning or using automated sound identification algorithms. So a lot of people who are mainly wildlife biologists and not data scientists can use our method to get estimates of relative abundance and species richness from audio recordings.